So chapter 5.4, which is multiplying and dividing radicals. And we're going to deal first with multiplying. Simple rule, the root must be the same, as opposed to when adding and subtracting where the entire radical must be the same. Here the root must be the same. So if we've got square root of 2 times square root of 10, this is simply 2 times 10 and keep the square root, which is the square root of 20. And remember to simplify because this is 4 times 5. So square root of 4 is 2, so 2 square root 5. (21) times square root of 21 times square root of 15, which is 21 times 15, which is the square root of 315. 315 is 9 times 35. So square root of 9 is 3 square root 35. 35 has no perfect squares in it. So you're more or less done at that point. The square root of 50 x to the 10th power times square root of 10x to the 7th power. So multiplying, we have 50 times 10 x to the 10th power times x to the 7th power. So this is 500 x, and remember when we multiply exponents with the same base, we add the powers. So this is x 10 plus 5, which is x to the 15th power. Sorry, 10, 7, not 5, 7. So 70. So x to the 17 power square root. So let's look at our options here. This is the square root. I'm purposely writing the square root here so we can divide. So we're going to put an x outside. Keep an x in here. 17 divided by 2 is 8 plus 1 remainder. So x to the 8th power plus 1 remainder. 1x in there remaining. And then we think about 500 is 100 times 5. So the square root of 100 is 10. 10 x to the 8th power square root 5x. Square root of 10, square root of 11 plus 7, square root of 7. So it's pretty obvious here that we would have to distribute. So distributing, we would get square root of 10 times 11 plus square root of 10 times 7, which is the square root of 110 plus the square root of 70. Neither 70 nor 110 have any perfect squares in them, so the problem at that point is solved. Square root of 5 into 5 minus square root 5. So distributing, we've got 5 square root 5 minus 5 times 5, which is 25. So this is 5 square root 5 minus 5. Square root of 25 is 5. Negative 10 plus square root of 6 times negative 4 plus the square root of 6. So you want to go ahead and do FOIL on this one. Absolutely, you want to do FOIL on this one. So first, negative 10 times negative 4. Outside, negative 10 times square root of 6. Inside, negative 4 times the square root of 6. And last, square root of 6 times the square root of 6. So this is positive 40. Negative 10 and negative 4 is negative 14 square root 6. And then the square root of 36 is 6. So final solution, collect 40 plus 6, we have 46 minus 14 square root 6. Now we can speak a little bit about conjugates. A plus B and A minus B are conjugates. Now, an interesting thing about conjugates is that if we consider A plus B, multiplying a radical conjugate by another, multiplying two radical conjugates, we call it this is a difference of squares, okay? And what's interesting here is that if we were to take, say, the square root of 7 minus 2, square root of 7 plus 2, this is simply the square root of 7 squared minus 2 squared. And if you square a square root, the square root sign goes away. So this is 7 minus 4, which is equal to 3. So multiplying a pair of conjugates in radicals yields a number that does not have a radical expression. In this case, we got 3. Let's look at other examples here. Square root of 5 plus 7, square root of 5 minus 7. So this is the square root of 5 squared minus 7 squared, which is 5 minus 49, or negative 44. 7 plus the square root of 2, 7 minus the square root of 2 is 7 squared. So minus, sign is always minus here, minus square root of 2 squared, which is 49 minus 2, or 47. This brings us to the process that is known as rationalizing. So dividing radicals. The general rule here is that we cannot have a radical on the denominator. So we use a process called rationalization. Rationalization to fix. The way this works is that if we have, say, 2 over the square root of 5, to rationalize this, we look at the square root of 5 and we multiply both numerator and denominator by the square root of 5. And this gives 2 square root of 5, and then square root of 5 times square root of 5 is 5. The square root is canceled out there. And there's no longer a radical on the denominator. If we've got, say, square root of 8 over square root of 75, so we need to consider fixing this first. This is 2 times 4 square root, and this is 3 times 25. When we get the perfect squares out, so the square root of 4 is 2, so this is 2 square root 2 over, and this is not the only way to do this problem, by the way, but it works for what we want to do. Sorry, that leaves 3 under here. I've got this backwards. This is square root of 25 is 5. It's really. So now we've got a square root of 3 here that can't happen. So we're going to multiply both numerator and denominator by the square root of 3. This gives 2 times 3 over 5 and the square root of 3 times the square root of 3 is 3. So this is 2 square root 6 over 15. Consider this problem. This is square root of 72 over the square root of 2. We actually don't need to rationalize anything here because the properties of square roots tell us that this is 72 divided by 2, which is the square root of 36, which is equal to 6. So we don't need to waste any time trying to rationalize that. Or perhaps the square root of the cube root of 162 over the cube root of 6. Again, just go ahead and put it into one single cube root, 162 over 6, which is the cube root of 27, which is equal to 3. Here's an interesting problem. This is the square root of 13x over 5. So now we're going to have to split the square root up to numerator and denominator, 13x over square root 5. And we rationalize by multiplying both numerator and denominator by the square root of x in order to make that denominator a square root. So what we've got here is the square root of 13x squared over x, square root of x times square root of x is x. And then 2 into 2 is one single x, and that leaves 13. Square root of 13 I'm sorry, this whole problem is incorrect. I put the square root of x. It's not the square root of x. It's the square root of 5. Let's go over this part here, square root of 5. We're multiplying by the square root of 5. I'm making things harder than we should there. Okay, now it's correct. So this is 13 times 5 is 65, square root x, and then the 5's cancel out. The square root of 5 cancels out with the square root of 5 to give 5. Okay? Square root of 5 times the square root of 5 is equal to 5. Square root of 18x to the power 9 divided by square root of 2x to the power 7. So you want to go ahead and combine this into a single square root, which is 18x to the power 9 over 2x to the power 7. So this is the square root of 9. And then we use the property, the exponent property of exponents here to subtract the powers. So this is, minus 7, minus 7. So this is the square root of 9x squared. So 2 into 2 is 1x, and the square root of 9 is 3. Square root of 48x to the power 9, 4x to the 4th power. Again, combining into a single square root, we've got 48x to the power 9 over 4x to the power 4. So this is the square root of 48 divided by 4 is 12. and x 9 power 9 minus 4. So this is 12x to the power 5 square root. So write your x out here, 2 into 5, 2 2s are 4, and one single x remaining. So the square root of 4 is 2, so we've got 2x squared, and remaining under the square root sign is 3x. Five x minus 4 square root plus 3, 5x minus 4 minus 3. So here we've conjugates. This is 5x minus 4 square root squared minus 3 squared. So squaring a square root removes the square root sign, so I have 5x minus 4 minus 9, which is 5x minus 13. So now we can go ahead and delve deeper into dividing radicals. And what we want to consider now is problems that have radicals on the denominator where we have to work on them. For example, if we've got 6 over the square root of 2 plus 1. In order to simplify this radical, we would have to multiply both numerator and denominator by the conjugate. So the conjugate of square root of 2 plus 1 is square root of 2 minus 1, square root of 2 minus 1. So this is 6 into square root of 2 minus 1 over square root of 2 squared minus 1 squared, which is 6 square root 2. I would 6 square root 2 minus 6. I would probably leave that alone like that. The square root of 2 is times square root of 2 is 2 minus 1. So this is 6 square root 2 minus 6 over 1. Don't need to put in the 1 here. I think it's okay to write this as 6 square root 2 minus 1 also. Okay. I've got 9 over 6 minus the square root of 3. So I multiply both numerator and denominator by the conjugate, which is 6 plus the square root of 3. That gives 9 into 6 plus the square root of 3. And on the denominator, I have a conjugate, so this is 6 squared minus square root of 3 squared. So I've got 9, 6 plus square root 3, 36 minus 3. So this is 9, 6 plus the square root of 3 over 33. And then notice that 3 into 9 goes 3 times, 3 into 33 goes 11 times. So this is 3 into 6 plus the square root of 3 divided by 11. Or you can distribute it out and get 18 plus 3 square root 3. Negative 126 over 7 plus square root of 7. Taking conjugates here, I have negative, 7 minus the square root of 7 over 7 minus the square root of 7. This is negative 126, 7 minus the square root of 7. Conjugates on the denominator to give 7 squared minus square root of 7 squared. So negative 126, 7 minus square root 7 over 49 minus 7, which is negative 126, 7 minus square root of 7 over 42. And we can divide 42 into 126 3 times. So this is negative 3 into 7 minus square root 7, which is negative 21 plus 3 square root 7. Let me just take a quick look at the homework, at the quiz, and see if there's anything that I notice in the quiz that would cause any concern. Chapter 5.4 quiz. Okay, you've got 8 questions in the quiz. I'm just looking at the ones that I didn't really do examples of. I can't see any major problems in the quiz here, so I'll just do one example from the quiz. 3 over 7 minus square root of 6. Rationalizing here, I have 7 plus the square root of 6. 7 plus the square root of 6. So this is 7 plus the square root of 6 divided by 7 squared minus square root of 6 squared, which is 3 into 7 plus the square root of 6 over 49 minus 6. 3 square root, sorry, 7 plus the square root of 6 divided by 6 minus 9. 9 minus 6 is 3, so 43. So this is 3 sevens 21 plus 3 square root 6 over 43. Okay.